So right now we are discussing ray optics. So you all are pretty much familiar with mirror equation. It is given by 1 by u plus 1 by v is equal to 1 by. So right now we are revising the things of ray optics. Okay, and also you are familiar with this quantity called magnification of a mirror. And that is given by m is equal to minus v by u. You can also write it as f divided by f minus u. Okay. Alright. Now what about area magnification? Aerial magnification is given by area of the image divided by area of the object. Okay, that is basically v square by u. That gives us m square. That is aerial magnification. And there is another important formula. If x is the distance of the object, and y is the distance of image, then there is this relation that xy is equal to f square, where f is the focal length of the mirror. Alright?
Yeah.
Good. So moving on to next thing, that is image formation. So you are familiar with image formation or what?
Yeah.
So let me ask you some basic question, okay? When the position of an object is between focus and center of curvature, this is the position of an object, okay? So position of image will be what?
It will be beyond C.
Very good. Beyond center of curvature.
Yeah.
Alright. Now we are not discussing uses of mirror, okay?
Okay.
Let's take an example. There is one question and it says find the position, magnification and nature. And nature of the image of an object placed at a distance 8 centimeter from convex mirror of radius 24 centimeter. Pretty easy question, right? Try to
Yeah.
do it.
Okay, okay.
This is the question. So, alright, let's solve it. So, here the object is placed at 8 centimeter. That means U is 8 centimeter. Object distance. That will be minus. Here R, that is radius of curvature, is 24 centimeter. So focal length would be plus 12 centimeter because the relation between radius of curvature and focal length is R by 2. You can roughly draw a sketch of an convex lens, and it looks like this one. Okay. So we can apply this formula here. So by plugging all the values, here we need to find image distance. So it will be 1 by f minus 1 by u. That gives us 1 by 12 centimeter minus 1 by minus 8 centimeter. That will be eventually 5 by 24 centimeter. That means our image distance is 24 by 5 centimeter, which is approximately 4.8 centimeter. Now if we talk about magnification, so magnification is nothing but minus V by U. So it will be simply minus 4.8 divided by minus 8. That gives us plus 0.6. The positive sign of M shows that the image is erect. And positive sign of V, that is our image distance, shows that the image is formed on the right side of the mirror. So it is a virtual image. Since magnification is less than 1 and it is diminished in size. Okay.
Okay.
Alright, let's move on to next question. Alright, so there is this typical question, and it talks about a rod of length 5 centimeters. So a rod is given whose length is 5 centimeters, and it is placed in front of a concave mirror. Alright, understood?
Yeah.
Here the focal length of concave mirror is given, that is 15 centimeters. In such a way that the end closer to the pole is 30 centimeters away from it. So this end, let's call this end A. Or you can say this end is B, this end is A. So it is 30 centimeters away. Find the length of the image. So we need to find the length of the image. Since here the length of the object is given, okay. So first what we are going to do, I am giving you a hint only, okay. I am not solving this question. First use this formula, okay. And from here you will end up with 1 by V, okay. And eventually you will get your answer for image distance,
Okay.
right? Now in order to
Yeah.
find the image distance, image length, just simply subtract it from this 30 centimeter, okay. That will be
Oh,
the image length, okay. So this is the trick,
yeah.
right? Don't ever forget this, okay. I'm sure you will
Yeah.
encounter this question in your exam, okay.
Okay.
All right. Let's take another pretty important and easy question. Question says the sum of diameter D subtends an angle theta radian at the pole of concave mirror. Let's say this is our concave mirror and this is our sun, okay, whose diameter is, let's say, AB. This is the pole. So they are saying that this diameter subtends an angle of theta at the pole, right?
Okay. Yeah.
So this angle is theta radian. Now focal length of this concave mirror is given, and that is f. So we are required to find out this is our sun. What is the diameter of the image of the sun formed by the mirror? So we need to find out the diameter of the image. So how we are gonna find out that thing? So first of all, this is our object distance, right? So again use this
Yeah.
formula, 1 by u plus 1 by v is equal to 1 by f. Here practically object distance is at infinity, right? Sun is too far away,
Yeah.
right?
Hmm.
So actually we are getting v is equal to f, yes or no? So at the focal length we are getting the
Oh,
image of the sun, yes or no? And
yeah.
of course we'll get it at the focal length, because you do remember that the rays which are coming from infinity, they are practically parallel rays, right? And parallel rays
Yeah. Yeah.
gets concentrated at the focus, right?
Yeah.
Okay. So that is image formed at the focus of the concave mirror. So let's say A dash B dash is the diameter of the image. Then we can write down theta is equal to A dash B dash. Let's say here we are getting A dash B dash, okay? You can write down A dash B dash upon PF, right?
Yeah.
This point is F. So you can see this triangle, right? A
Yeah.
dash, B dash. This is B dash, okay? This is F. This is P.
Okay.
So A dash B dash upon this PF, this perpendicular. That is the property, right?
Yeah.
Which would be vertically D by F, right? We are considering A dash B dash and its diameter as small d. So this is the relation, okay? D is equal to F theta. So you can actually remember this formula, okay? When any object which is too far away from a concave mirror, you can always find out its relation with the focal length and angle as D is equal to F theta. Understood?
Yeah.
Now, very important point, number of images formed by two inclined plane mirrors. What it is? Hmm?
What was the question?
This is a very important point. The number of images formed by two inclined plane mirrors. Okay? So if an object is placed between two mirrors facing each other at some angle, so let's say this is our first mirror. Right now we are talking about plane mirror, okay? This is
Okay.
another mirror, okay? So if you place an object here, let's say at this point, okay? So this mirror will also form its
Okay.
image and this one will also form image, right? Now this one's image will become
Yeah.
this one's object, right? And vice versa, right?
Yeah. Yeah.
So the number of image formed is given by n is equal to 360 divided by theta minus 1, okay?
Okay.
Remember when 360 divided by theta is even number, okay?
Okay.
Now it is given by 360 divided by theta minus 1 when 360 divided by theta is odd and the object lies symmetrically. Object lies symmetrically, okay?
Okay.
Number of images is given by 360 by theta when 360 by theta is odd but object is asymmetric, okay? Or unsymmetric.
Okay.
And it is given by 360 by theta. The greatest integer less than 360 by theta when it is a fraction, okay? So tell me, when two of these mirrors are parallel to each other, then what will happen? How many number of images you'll get?
Infinite.
Very good. So there are lot of things, okay?
Okay.
Always remember, on reflection, the velocity, wavelength, and the frequency of light remains unchanged, but the phase changes by pi when reflected from a surface, okay?
Okay.
Focal length of a plane mirror is infinity, and hence its power is how much?
Uh, 1 by f.
0. Its power is 0.
Oh, 0.
Now let's talk about refraction. So you are familiar with refraction or not?
Yeah.
Good.